Hey everybody, today we're going to be talking about conditional logic in coding. That is using if and then statements to program our games and our characters and any other objects in our games so that we can really create something that makes a lot of sense. So basically the point of all this is to understand how we can use logic in coding our games, which will be used to set up any movement or actions in our games and also create an interactive environment that our players and our users can then experience instead of just watch. So the first question is, of course, what is logic? Logic is basically a set of rules or sequence of steps that defines an action or process. It's basically the things that are used in order to define what it is that you're creating. So it can be anything from the physics of your environment to the way things interact with each other. So in coding, it tells different elements how to respond to various things in a way that makes sense for their world. So one of the things you might be familiar with from science class is there's a stimulus and a response. In coding, especially in logical coding and conditional statements like we're using, it's that stimulus and response relationship that we are setting up. We are defining what happens, what that response is if a stimulus occurs. So for each stimulus, it triggers a specific response or reaction for each element. So in our world, depending on what we decide the reaction or response is going to be, that will define the environment, that will define how your users will interact with the game. So logical statements in the coding world are called conditional statements. And most programming logic is in the form of these conditional statements, which are called Boolean values. They're based on things that are either true or false. That's basically what Boolean means. So basically a question is asked, and if that question or statement is true, then a certain thing will happen. And then if that statement is false, something different will happen, or even nothing will happen at all. So think about a ball. You're holding it up in the air. So is the ball held in a hand? Then yes, that's true. The ball is in a hand. So if the ball is in a hand, it's not going to happen. It's going to stay there. If the ball is let go, if that's a true statement, the ball has been let go, then it's going to fall. If it is not let go, then it is not going to fall. So it's logic like that, like, okay, if this, then that happens. Or if nothing is happening, if that's not true, then another action might come up. So basically, it's a bunch of things that are if-then scenarios. And if-then scenarios like, well, if this happens, then that happens. So there's a logic to something that follows something else. It's cause and effect. So I underlined here if, then, and else, because these are actual terms that are used to phrase your codes so that it can look logical and you can have different steps follow from one to the next. So basically the pattern is if something is true or if something happens, then do this. Causes something else to happen. If the first part is not true, then you get to the else part, or otherwise. This is what happens instead, if anything at all. So for an example, if the right arrow is pressed, then move the ball to the right by 5 steps. Else, that is, if the right arrow isn't pressed, don't move the ball. So before you actually write your code, you would write a sentence like this, or at least think of a sentence like this, and that describes an action that will happen in your game. So if you have a ball in your game and you want it to move to the right, you'll press your right arrow key. How fast and how far do you want it to move? By 5 steps. Now you don't always have to put in an else statement, because if you have an else statement that basically says don't move the ball isn't going to move unless that first statement is true anyway. So you don't need to say else don't move the ball. It would just be if the right arrow is pressed, then move the ball to the right by 5 steps. All you need to know is if that first statement is true, then do the action. But sometimes you will want to put something in there that says, if the right arrow is pressed, move the ball to the right by 5 steps, else just drop to the bottom. Something like that. You could, unless you're throwing the ball, have it just drop when it's let go. That kind of thing. Some more examples of some conditional statements or some ideas to think about is that each sprite, which is any object or character in your game, each one of those things needs to be logically programmed independently to tell it what to do in any possible situation within the world of your game. Now, that's a long sentence. I apologize for that, but it really tells a lot. Everything that you have, everything that you include in your game, it needs to have some programming to it to tell it what to do in your game. And any possible situation within your game needs to be played out. So if you have a character that is able to, stand, sit or crouch, lay down, walk, run, jump, throw, look up and down, left or right, hold a weapon, fire a weapon, aim a weapon, however that is going to happen, whatever the stances are, the poses, every single part of that needs to be thought out about what happens when the different controls are played out, and which controls will control any of those too, whether it has to do with a mouse click or a key combination on the keyboard, the arrow keys. If it interacts with something, does it automatically, pick it up? So you have to decide what actions you want your characters and your sprites to be able to do, and then once you define that set of actions or behaviors, then you can jump into how you're going to make that happen. Can you do certain movements in combination? Can you look up and aim up in order to shoot, or are you stuck to only shooting straight out in front of you? That sort of thing. And so the more complex of the game that you develop and the more possible situations that the sprite will be in means the more logic you need to program. So when we're starting off here, especially with your assignments this week, you want to keep your stuff simple. You're just learning some of the basics. I'm not asking anybody to come up with something super complicated, but just know that the more you add in, the more you need to program. That even goes for background elements. So say you have a tree that is part of your environment. It can be a static tree and just be there. No big deal. Sometimes that can work. You leave just a static tree. But what if you want your tree to sway in the breeze, or have the leaves fall from the branches, or something like that? You have to program each of those leaves to fall, and when it's going to fall. You have to put timing into it. Sometimes you might add sound effects. Perhaps it's going to not just fall straight down, but it kind of sways back and forth so that it floats down, and you'll have to program that movement as well. So even things you might not think of as vital, but the small details that really make your environment and set up your world, those are things that also need to be programmed. And remember, anything that you don't tell it what to do, it's not going to do anything at all. So if you don't tell your character that it can do something, it doesn't know that it can do it. And so it's not going to do it. So if you have a character that's running around, but it can't crouch to get under a certain opening, well, then I guess you're stuck and your character can't get to that next level or that next room. So make sure that if you want something to do anything, you have to tell it what to do. So basically, you're creating a world that requires rules that all sprites follow, so that all the pieces logically fit together and belong. So basically, the rules you set up need to be true throughout. The rules require that your world makes sense. So you don't want to have different characters that are able to move in different ways. That wouldn't make sense. You wouldn't want two characters that are essentially the same to be able to walk or float in the world differently without some sort of explanation behind it. And so you want to make sure that everything you are creating makes sense for that world. So basically, in your environment, everything has to interact with each other using that same set of rules. You can't have a character that can walk around in space and another one that just floats, because in the same environment, both of those characters would essentially be doing the same thing. I think about the movie Star Trek, or really any space movie that has characters that don't really float while they're moving around in a spaceship. They're walking down hallways or running down hallways on the ship, when the science of it means they'd be floating around. And so if it's true for one, it needs to be true for everybody. So unless you're having like a droid or something that can levitate and that sort of thing, that's a different story. But that's explained away so that is something that is truly acceptable in that world and in that environment. So it's not unexpected. But you wouldn't expect Han Solo to be walking and Chewie to be like floating around as they're walking through the Death Star or something like that. It just doesn't make sense to do that way. You want to make sure that if everybody floats, then everybody floats. Or if they can walk, everybody walks. You want it to make sense. So that how the different characters and sprites and things interact with the environment makes sense. So there's the interactivity of elements within the environment, but then there's also interactivity between the user and the actual characters in the game, or the different objects in the game, the sprites. So basically, here we go. If a ball hits or touches a wall, then you want to change direction and keep moving, else keep moving in the same direction. Here we have some physical elements. Here's like the laws of motion that we talked about with Mr. Thompson, that an object in motion remains in motion unless acted upon by an outside force. So if a ball doesn't run into anything, it's just going to keep moving forward. Left to right, up, top to bottom, whatever direction it's going to just keep moving. But if that ball then hits a wall, that ball is going to bounce. So, or it's going to explode. You can choose. But you have to decide what happens when these different elements interact with other elements. So if the ball bounces, you get to choose, is it going to bounce directly straight back where it came from? Or is it going to bounce in a different direction? And so kind of bounce all over the screen. So basically you set up the scenario, okay, what happens when a ball hits something? Okay, so if the ball hits a wall, it's going to change the direction and it's going to keep moving. You can have it speed up, you can have it go at the same speed or slow down. It's your decision. But you have to come up with the idea. So you get some interactivity now with the player. If a space bar is pressed, then you're going to fire a weapon. Here you program into the actual sprite of the projectile, whether it's like a laser or a bullet or whatever, or a grenade or cannon or something like that. When you hit the space bar, it triggers a movement in that sprite. So whatever the bullet is, you would then program into the bullet to watch for when the space bar is pressed, and once it's pressed, it moves in a certain direction at a certain speed in a certain way. Whether it's really quickly, or it comes out 3 at a time, or whatever it might be. Same thing with, let's say, a zombie game. If a zombie gets hit 3 times, then the zombie dies. So you have to have some counters set up, but like whenever it comes in contact with a specific element, in this case like a bullet, then it will die. If it bumps into a wall 3 times, it's not going to do anything. So you have to program all this stuff together to figure out how sprites interact with the environment and how we as players can interact with the environment as well and kind of control it. So basically, interactivity, it sets up your world. All this logic and conditional statements and interactivity, it sets up the world. It creates the environment that you're working in. One of the things I mentioned in class was, the idea of suspending your disbelief. This is something that comes up in movies and storytelling all the time. You want to set up a world so that your viewer, your player, can become immersed in it. They can suspend whatever it is that they see as realistic and normal. They can set that aside for a little while so that they can then fully enjoy the experience. It needs to make sense for that world. Obviously, I don't think lightsabers really work. We know scientifically that, they're always working on it, but they're not there. So I walk into Star Wars and I understand that, okay, in this world, these things exist. And it makes sense, and they use it in a way that makes sense for this world. I can suspend my powers of disbelief. But once I start seeing things that just wouldn't fit, like even if it's a coffee cup that has a Starbucks logo on it that shows up on a TV show that's set, in a different period of time in a fictional place where there is no Starbucks, that kind of disrupts the experience, right? Sure, it's fun, it's funny, but it disrupts. So you want to make sure everything you create, all the logic and the rules you set up, make sense for this environment. This can also provide advantages and disadvantages and goals or points and different ways to move the game along. I think a prime example of this is in Mario. There are different elements that you don't interact with, like background bushes or clouds or anything like that really don't make any difference. But once you insert things like the bricks and the blocks that you can jump on and either bump with your head or break, all of those things make it more interactive. It also allows for the ability to get advantages like, you hit a block and a mushroom pops out that makes you bigger, or you get a fire flower that makes you be able to shoot, or a feather that makes you able to fly, or Yoshi pops out. Any number of things can happen. It also provides disadvantages of how things interact with each other. Like if you get hit with a shell, or you accidentally touch one of those plants coming out of a pipe, or if you fall down into a crevice, you immediately die. You can't just climb out or jump out in some way. That's providing a disadvantage because of how you interact with that space. And with goals, obviously coins. If you jump up and hit a block and a coin pops out, you get the point. If you run through or jump and catch a bunch of coins, you get the extra points and you ultimately get a free life. So all these things are set up as far as interactivity goes. It gives you and your players something to shoot for, something to try to achieve, and it also gives you things that you want to avoid. It's something you learn very quickly when you play, that you're going to lose a life if you keep making these same mistakes. So it helps guide you through the game, and it helps provide interest and excitement. And part of that is also adding depth to the experience. You want people to look at it and play it and feel like they're drawn into it, that it's more than just a surface kind of game that's two-dimensional and boring. It adds something to the experience. And ultimately, it draws the player deeper in. The better the experience, the more somebody feels immersed in it and part of it, the more they're going to want to play, the more they're going to tell their friends about it. They're going to want to buy it, buy the sequels. They're going to become advocates for you. Buy more games from this person because they make really cool stuff. So make sure that you're paying attention to the logic and the rules you set up to make sure that your games are complete, they are complex, and they're worth playing. So the assignment, which is already in Google Classroom, it's due this Friday. I'm just going to walk through it here a little bit. We have a few different requirements for this assignment. It's basically to create a Scratch game using at least 2 sprites. You can use predefined sprites from the library. You can create shapes. You can import other imagery that you can use as sprites. It's up to you. You need to use a stage that is not a plain color. You can upload a photo of your own that is of some sort of environment you want a game to be made into. You also can use one of the many images in the library. You need to make sure your sprites move based on some sort of player's action, whether it's hitting the green start button or pressing a key on the keyboard or moving your mouse. However it is, you have to have your sprite move in some way or change in some way. And you need to set up a reset button that returns the sprites to a preset location. Now, this all sounds a little complicated. I know it can be intimidating for some of you. But basically, if you watch the video that's attached to the assignment, you can then follow it step by step and recreate that same scene, and I will count it. because it has two sprites. It's using a space background, star field, that is not a plain color. So there's your first two right there. The sprites move based on the player's actions. So as you're playing, you're hitting the start button and immediately the sprites move. If you hit it again, they move again. And there's obviously that circle that's set up as a reset button to put everything back in an original position. So even just following that, you're able to complete this assignment. This is basically to make sure you are following the rules and able to create something that is functional. It gets you familiar and a little bit more comfortable with Scratch altogether. So what's next? You want to set up your Scratch account for our class. Go into Google Classroom and use the link there for Scratch class registration. That way you can log in and set up your own account that's automatically connected to our class. It gives you access to our class studios, so you have a place to add your finished assignments. If you haven't done so already, do the Ed Puzzle, Scratch for Beginners, that is in Google Classroom. It's a great introduction to the workspace and how to complete certain tasks in Scratch. This is also a great reference to hold on to as we move forward to get some of those basic fundamental ideas cemented in. Once you have done those couple of things, work on your assignment. It's due this Friday, so make sure you're spending some time getting comfortable with Scratch and trying it out, get your feet wet, and it's going to work out fine for you. But work on that. It shouldn't take you too long if you follow the steps even in the video. And then Thursday, which is tomorrow, or if you can't make it to the session, make sure that you go back in to the student-led, student-paced version of the Nearpod. I'm going to set up a game for us to review all the concepts of Scratch that we've gone over so far, as well as conditional statements that we referred to in this video, so that you are ready to go for when we start developing a little bit more next week. If you have any questions, of course, reach out on Remind, comments in Google Classroom, or send me an email, and we'll see what we can do for you. Good luck with your projects. Make sure that you're looking back at all the requirements that are there, and we'll see you next time.